In this video, I'm going to look at a Sanyo DCX2000. Now, this is a vintage AM/FM receiver made by Sanyo, and we have a couple problems on this one. One of them is it's got severe distortion, but the left channel is also very low compared to the right. That's coming up next on Tech Talk. To quote Jack Nicholson from A Few Good Men, don't I feel like a I just started this video and then I realized that I didn't have a memory card in the camera, so I have to start over again. This is the power switch here. It's a pull off, push on. Okay, that part works. The AM works. Let's try FM. Doesn't sound very good, does it? Left channel doesn't sound very good. Controls are dirty, for starters. Okay, so the controls are dirty. It's really distorted too. Oh, that works. We have a dirty switch here. Really distorted. Wow. Yeah, this is really bad. The FM is severely distorted on this thing. So we have our work cut out for us on this one. One channel louder than the other in mono, but well, I think first things first, we'll clean that switch and start there. Well, the first thing we can see on this is it uses STK016 power modules. So this is a 16 watt per channel receiver. Not a very high power unit. This is a very low end unit, and I mean, you can tell just from the size of the power transformer this thing's not going to have much power. Anyway, let's see what's causing all this noise, all this distortion. Obviously there's a problem somewhere either in the FM stereo demodulating circuit, or we'll start out by cleaning that switch because we know that it's bad, all the noise we get off that. So to get at the switch, I can do that from taking the bottom off. Hey, this unit was made in Japan, but again, Sanyo of the day, they weren't considered to be like one of the premier manufacturers. They were a low-end manufacturer. Their stuff wasn't bad. I mean, certainly there was worse stuff out there than Sanyo, but Sanyo was never considered to be a high-end brand. You had the Technics and Sony and Kenwood and Pioneer. They were the high end of the Japanese brands, and then you had Carver and a few others that were Macintosh, which were the high end American brands, NAD, British, although most of the stuff wasn't made there, but it was designed there, and many other companies. So here's our switch down here that we need to clean. We'll just get some cleaner in there. So we'll get our contact cleaner in the switch here. And we'll see how it sounds. Still very distorted. Very distorted sound on this thing. So first I need to determine whether the distortion is just coming from the radio or whether we have distortion on our auxiliary input as well. So what I've done is I've connected my DAT player here, and I've got some music feeding in, and we'll just take a listen to the sound from the auxiliary inputs. Okay, the right channel sounds okay. left channel, there's nothing there. Very low sound. So we may have a problem in our, that's the right channel there. We may have a problem on this power module. We'll put the scope on it and take a look at our signal going through the power module. Okay, now we have the scope connected to the left channel input. As you can see here, well, music's between songs now, so we'll wait for the next track to start. But as you'll see, we have our input. So this is our left channel input. If I go to the right channel, you'll see that we have sound, but we have nothing here. Here's the left channel, but we have very low output. It's clean though, eh? Just no bass, but our input's good. And then our right channel is this one over here. Right, this is the right channel. So we have input. We don't have any output, so we may have a bad module, or we may have one of the capacitors in that circuit is acting up. So I'm just going to go and print out a pinout for one of those modules, and then we can work our way through that circuit. Also, we look at our input from the FM radio. You'll see that it's all distorted on the right channel. Where's the left channel here? It's all distorted, right? So we have a problem. We have a problem with the radio as well. We have two problems with this thing. We have no sound out of the left channel, but we are low sound out of the left channel, but we've also got severe distortion on the FM. So this one should be an interesting fix. Now, as you can see from the schematic diagram, this is the internal schematic for the STK016, and we have our input on pin number 6 here. The circuitry, it's a thick film design, so internal to this is 1, 2, 3, 4, 5, 6, 7, 8 transistors, right? And you provide your input, you provide your voltages, you get an output. The output is off of pin 2, and if we notice down here on the schematic, the block diagram, we have 3 capacitors that are involved, and 2 of them are bypass capacitors working in the negative feedback circuit and such. That's C2 and C3. C3 is your negative feedback, I believe. That's your negative feedback circuit. Capacitor between pin 9 and pin 10, if we look up here, is coupling from the driver to the output stage. But the big one is C4, which is, in this case, it'll be a 2200 microfarad at 35 volts. And if you notice, C4, all of the audio, this is the audio output capacitor. So this is the capacitive coupled output to drive the speaker. So if that cap were to go open, for example, you would not get much signal through it. And that's exactly what we are having here, is we're having very little signal. So there's a good chance that it's the 2200 microfarad capacitor has failed on this unit. So that'll be the first one we check, will be the 2200 mic, 35 volt. I probably got one of those in stock here. Let's take a look and see, and we'll get that one changed out first and see if that will bring my levels back. And if I can get my levels balanced between my left and right channel, then we can start working on the FM circuit and find out why it's so distorted. Okay, here's the capacitor I'm going to change. In this case, it's a 35 volt 1000 microfarad here. I'm going to change this one and just see whether it brings my level up on the left channel. So I'm just waiting for the iron to warm up here a bit. We like you can test this thing, see whether it's lost any farads. So it still has its capacity. We'll check it for ESR. Looks to be good. So the cap might be okay. It might be the module itself, but we'll try. I'm just going to tack it in from the bottom. There's no point in putting it through the board if it's not going to fix it. We'll see if that gives us any more volume on the left channel out of this thing. So our output's still low, so we know it's not the output capacitor. Might be one of the other ones that's gone bad. We'll check a few of the other ones out, but I'll put the original one back in because it's fine. The next most likely capacitor that's going to be is the coupling cap that's between pin 10 and 9, because that's where the output from the pre-driver stage here, TR1 internal, is coupled into the power amplifier. So if that one were to go open, you'd expect to have low sound, which is what we have. So let's try that one. And that is going to be this one right here between pin 10 and pin number 9, which is this one right here. It's this one right there. So let's swap that one out. I can probably just bridge this thing on the bottom of the board. For that matter, that might be easier. Let's just bridge it here. Pin 10 is the positive side, I believe. No, pin 9 is the positive side. So we'll just bridge this one right across here. Okay, we'll try the power now. Did it. There it is. Right channel. Left channel. Okay, that's got the amplifier fixed. Let's replace that capacitor. Let's do the right job. Bridging it improved that it does work. So next, we'll just change that cap right out. So I don't need my scope on here anymore, at least not for this part of the job. And yeah, this is the right size. This is how small a 10 microfarad cap is now, 25 volts, which is what the original one is. Now, take a look at this one that's going to come out of this thing. It's huge by comparison. Oh yeah, the pin came right off of it. Like this one's completely shot. You can pull the pin through from the bottom here. Or maybe not. Take it through the other side. There we go. Okay. Yeah, they had it in the right way. I was looking at it there momentarily thinking maybe they had it in the wrong polarity, but it was incorrect. But anyway, look at the size difference here, right? Here's what came out. That's what's going in. These are both the same, right? Actually, they're not. Schematic says 10, and I put a 10 in, but the original is a 47. So let's go get the original one. My schematic here, this is just a generic, so it's different value. But anyway, still quite the size difference, though, right? This is the new one, a lot smaller than the original. Okay, power. There we go. So, that's got that fixed. Now we have to tackle the FM, and so that I can run some test music over FM without having to worry about getting clobbered with copyright, I'm going to go and get my little FM transmitter, and I'll get some Music Bakery stuff loaded up on it, and we have our own little test channel that we can test. So let me do that, and then we can start working on the FM circuit. So you guys have probably seen these things before, right? You put them in your car, you plug them into your lighter. On this one I just added some external inputs on it, but it has a USB socket on the bottom, and I just plug my USB stick into here and power this thing up. I made a little antenna for it, a little extra long antenna here, so this thing can now goes several hundred feet. So I can power this thing up, tune it to a blank spot on the dial, and I've got my own personal FM transmitter loaded up with some royalty-free music from the Music Bakery. I'm just going to plug this thing in, set it up, and then we can go and test the FM front end on this thing and see why we've got so much distortion. So I've got this thing tuned down at 87.9. Let's find it. There it is. That's perfect, because now I have this channel all distorted. Go to mono. How's that sound? See, we're distorted on both. Not as bad in mono as it is in stereo. Let's just take a look at it with the scope. I gotta watch the volume here too, because the camera is really close to the speaker, so you won't hear me talking if I got any volume here. I'm just looking at the waveform on the scope here, and it is kill the speakers. Yeah, it's pretty distorted. With a stereo, and it's really distorted on the scope. Yuck, it's terrible. So what I'm doing right now is I'm just looking at some of the, it's hard to see on this because it's so bright in here and this scope is incredibly dim. But this is my subcarrier, right? My 19 kilohertz, my subcarrier regeneration for the FM stereo demodulator. If I turn off some of the lights in here, this will show up a little better. This scope is not the brightest in the world. I can see it. I can see it better than what shows up on camera, but it's not the brightest, that's for sure. Mono has no, of course I'm turning off the stereo, right? We're in mono now. Now we're back in stereo. You guys can't hear this now because I put headphones on to listen to it, but it is very distorted. This is, I'm actually playing a commercial station here, so I can't run this music. But the little car modulator thing is fine, but the thing is the level of it's much lower than a commercial station, and even though it sounded pretty good on that and I wasn't hearing a lot of distortion, when I went back to a commercial station with the full 200 kilohertz modulation, well, let's just say that the distortion's unbearable. So I'm just going to do and measurements listening through my headphones here. You guys obviously won't be able to hear what I'm doing, but when I find something I'll certainly let you guys know what I found. But as you can see, this signal here is clean coming out of this detector here, so it might be inside the stereo IC or one of the support components around here. That's where the distortion is. So I'm just checking the signals coming off the decoder IC, looking for distortion. That's not too bad, that one. Oh, interesting. It's distorting on AM too. It's in the amplifier. Okay, our distortion it's not doing it on the auxiliary input. It's doing it on AM and FM. So something in common to the two radio stages before it gets to the amplifier. Let's just see if it's distorted going into the amplifier. It seems to be clean coming off that board. Let me just take a look at the signal going into the amplifier here. So here's our, you see here, volume. See our distortion here, right? This is going into the power modules. So between the radio board and the power amplifier, we're getting really severe distortion. Interesting. This is a strange beast, this one. Okay, take a look at this little preamp board here. Here's the signal going in. Clean signal going in. Here's our output. Distortion. Our problem is on this board. What exactly is that board? I'm thinking maybe one of these caps has gone bad in this power supply for this. This is the preamp, and if I put my finger around in here, the distortion goes down. Just gotta check a few of these caps in this area here. Something on this circuit board here is where all my distortion is coming from. We can measure it. We can see a clean signal going in and a much stronger signal that is really distorted coming out. And I'll show you. If I put my scope on here, I don't even have to have any sound going for you guys to see this. Put the scope on here and just clip onto one of the outputs here. You see that distortion. If I just put my finger and just, where was it here? If I just put my finger down into here. See, now it's cleared up. Just touch the circuit. So the transistors are being driven into maximum gain. And we may have a leaky cap or one that's gone open. I'm going to take this little cap out here. It's a 10 at 25. See if we can get this one out of the board. Okay, let's check this one out. Oh, this one looks like it's been leaking. I'm sure this one's probably the one. There's probably one on each side that's bad. Let's just take a look at this one. ESR. Open. I bet you that's it. It's that cap there, and the other one is going to be that one. Let's get a couple of 10 microfarad at 25 volts, and we'll replace both of those. What are these? Those are 47, a little high. Try and find a couple of 10s. There's one. We'll get the other one out of here too. I'm sure this one's also bad. ESR wise. Yep, completely open. Well, that'll certainly do it. Incidentally, this is right in the area where I was putting my finger, and it cleared up the sound. Okay, guys, ready to hear this? See if it works? Let's turn the speakers on so you guys can hear if it works. Something's on the off channel. There's a little bit out, but we're not getting the distortion we were getting. We're making progress. I think possibly I have another bad cap on the left side here. If I crank it up here. Okay. Left channel. Right channel. Right channel's okay now. I think one of the ones on the left side here, we may have another bad one over on this side. So I'll investigate a little further. Okay, I've changed another capacitor here, this one here. Second one over right here. That one there as well. So here's the caps we ended up changing. I changed this one. I changed that one. I changed that one. Now it sounds great. There we go. I'll take it down to my little there we go. It sounds great. How about loudness? Gotta spray some cleaner into the switches. Where are those switches? Maybe I got cleaner into there, I think. Hate it when this happens. My headphone adapter just snapped off inside the receiver. Get the chunk out of there. Not one thing, it's another. work at getting that piece out. Problem is I need that adapter, as it's the only pair of headphones I've got, and they've got a 3.5-inch plug on them, and half my stuff in the studio is 1/4 inch. So I'm gonna go get myself another adapter. I'll see if I can push this other one out from the back here. I hate it when this happens. There we go. Got it out. Piece of junk. Okay, we'll do another test on this thing. And I'll put it together. Power on. There we go. It's all done. Sounding great. Again, this is a signal that's coming from my little $5 that I bought at the dollar store. I think it was $5. It's an MP3 player with a FM modulator built in, so it's not the best sounding, but hey, it does the job, eh?
On-site 24 hours a day.
I don't have an antenna on this thing either, so.
The high level of care your pet requires. Time is of the essence. When your pet's faced with a life-threatening emergency over the holiday, your option is the Animal Emergency Clinic of the Fraser Valley. 64th and 204th in Langley.
Trust me, you never want to take your pet there. Any of those places. I have a story about a cat that I got. I adopted a kitten last year. And it got sick after about a week, and it was on a long weekend, of course. So our normal vet said, "Oh, we're closed for the weekend. You better take it to the emergency clinic because it might not live over the weekend." And the story, the cat is alive and it's huge now. The thing weighs like 20 pounds. I think you've probably seen him in some of my videos. Not lately though. You wouldn't recognize him now. The thing's huge. It's a rag doll. But the bill was like $1,500. They're just the biggest ripoff, but anyway, hey, it's working. Nice old Sanyo. Nice old Sanyo classic receiver. Say, was low end in the day, but by today's standards, it's not a very powerful unit, but you know what? That doesn't sound bad. We'll catch you in the next one. Bye for now.